Hey guys, so today let's create a platform on base. Rather, I should say, let's vibe code it. We'll build on Matterhorn entirely. We'll create the contracts, deploy, and create the user interface as well. And let's build on the base chain. Let's figure out if we can, or let's build on Ethereum, and then let's figure out if we can also add any privacy preserving protocols such as Zama onto the application. So let's open a new folder. So project 11, select folder, wait for the dev environment to be set up. So let's build with forms. So let's build, say, a clone of Uniswap. Let's give a description. This goes into our agent. Let's build a clone of Uniswap on Ethereum. Also create an ERC20 token that can be given as rewards for those who trade on the platform. Next, so this would be DeFi. Project type, it would be an exchange. Let's do it on Ethereum. No additional configuration required. Any specific colors? Let's make it maybe grayish. Yeah, grayish purple. Professional design. Let's create the project. Now, generate project documentation. So requirements, design, contract tasks. Let's generate all of it and auto-generate all the steps. We'll wait for the steps to complete. Then we'll go to the next section. So as you can see, the first part, the requirement documents have been generated. Let's wait for the design and then the tasks to generate the contracts. Let's wait for those also. Alternatively, I can just chat on the right-hand side here for, to build. But on the other hand, I can just build through the user interface. So I can do both right now. Let me take you through the other parts of the platform. So the design is done while the contract tasks are being generated. So here you can see we have the chat settings where we have you can select the type of model that you'd like to use for chat project generation, validation, analysis, testing. This is where all the files will get generated for the project. And here you can collect wallet. So you can use wallet connect, or you can just enter a private key. I'll enter the private key for this use case. Here you can see the contract documentation is also complete. Now let's go ahead and start implementation. So let's start implementation. So we have token contract, price oracle, pool contract, factory and router contracts. Let's run task to generate all these smart contracts, and we'll wait for these to get completed. So I just wanted to show this. As the contracts are getting generated, you can see, what the agent is doing. So progress, the agent's understanding context, writing code, how many lines it's writing, what type of code is it writing, is it compiling, checking for this compilation is done, running a security analysis. All these details are being, all these processes are being done all at the back end. Right now, I've chosen the Matterhorn Ultra agent, but you can choose any mode that you'd like to build this. So let's wait for this to get completed. Should complete pretty soon, I'm hoping. Yes, let it run the security analysis. Then we should see token contracts being completed. Then we'll go to the next section. So guys, as you can see, the Token contract has been completed. Let me run the other three tasks as well. And I'll let you know once those are done, and then we should be able to generate the front end and deploy the application. Um, Once the other two are also done, in the next maybe 7 to 9 minutes, we should be able to see everything else. So, as you can see, implementing the price oracle contract, writing the interface contract and the test files, writing code. Let's wait for this to complete, and then we should be able to go to the next section to build the front end connectors for the contracts. Okay, guys, so we are done with the token contracts, the price oracle. We're almost done with the pool contracts as well. Now we should try, once we're done with the factory and router contract, let's then generate the front end. Maybe we could explore what could be the use case for confidentiality or privacy in this Uniswap clone. Do you want to hide the amount of the transaction that or trade that you're doing? We could explore that. Let's explore that once we're done with the contracts and see how the contracts can be changed with the requirement of privacy that we have. Okay, guys, so we are almost done with the pool contract. Um, there is an error, but then certain tests are passing. Once the pool contract is completed, we'll go to the factory and router contract. And then let's see if we can integrate any form of privacy. So guys, the pool contract is completed. Now let's go to the factory and router contract. Let's run this as well. Um, as soon as it's done, this shouldn't take all that long. This one took about 6.5, 7 minutes. This one about 4 minutes. This one about 3 minutes. Once this executes, or sorry, once it completes, then let's go ahead and generate the front end. So guys, we are done. All the contracts have been created. Let's see if we can integrate. Can you check the contracts that are created and see if you can integrate Zama for FHE for just enabling confidentiality of the trade amount. Let's see if we can integrate. If not, we'll just go ahead, deploy the contracts and create the front end. So, yep, I think it's certainly possible. Let's wait for this to complete. It's reading the contracts that have been created. Yep, it's an AMM DEX with pool and router. New contract that indicates RMIS. It will allow users to swap tokens without giving the trade amounts encrypted on chain. Yep, that's right. There you go. Confidential swap. This is the contract that has been written. We'll wait for the AI to see how these contracts can be integrated. As you can see, it's being updated as we speak, but there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost about 15 contracts. So let's see which ones can get updated. Created confidential pool for 600 lines total. Um, Once these are updated, let's then see. We'll then go to deploying the contracts and then generating the front end. So we're almost done. Um, let's look at, so as you can see, it's analyzed the contracts, created confidential router contract as well as the confidential pool contract, and configuring Foundry to support the newer version. I think this would be more for deployment. And yeah, I think once this is done, uh, once this is done, we should be ready to deploy and then generate the front end. So guys, I think the whole integration is complete. As you can see here, Zama FHE integration complete. New files have been created. The entire flow has been created. Around 2,400 credits. Everything has been done. So let's now continue to deployment of the contracts. So I'll just use the private key for deployment. Let's see if we can deploy all. We'll have to enter the address, so let's deploy one by one. So this is deployed. Let's copy this address. Keep this as the factory address with the confidential router, and let's deploy here. And keep the same address as the owner, actually. Then we can deploy that as well. And then we can keep the same address as the owner and then deploy this as well. It's deployed. Reward token. Let's keep the same one here. Reward token, once the reward token is deployed, let's deploy the router contract. Token A, address, token B, address, Oracle address. I think we can just give dummy addresses here for now. Or maybe we just take a USDT or USDC address from the test net and then put those. Let me just add those. So I've entered a dummy address. So token A was USDC on Sepolia. Token B was USDT on Sepolia and a sample chain link address that I've taken on Sepolia. LP token, let's call it trial one, TR1. The pool address, I think we should be able to just take the confidential pool address from here. Deploy. We'll use the same token A, token B addresses here as well. So it's deployed. Token A to B and Oracle address. Here's the same one. Let's deploy. Reward token address, initial owner address, I think will be my initial address. I can just use here. Reward token address would be the reward token address that's here. The Oracle address would be the same as that I entered here. It's a sample address I took on Chainlink Sepolia address. This should be deployment should be completed of all the contracts. Yes, all of them have been deployed. Now let's see if we can go to the front end. Generate front end documentation. And then let's generate the front end. So here we have generated the front end documentation. Let's start implementing the front end and then excited to see what we generate. So we should be able to run all the tasks and let's see what we generate after this. Okay, guys, so we're done with 3 of the front end tasks. We'll complete the remaining 2. And then let's move on to deployment with Versal. Excited to see what we can deploy. Okay, guys, we're almost done. The last front-end task. And then let's go into deployment. We should be able to deploy with Versal. And let's see what we've generated. Curious and excited. Should be done soon. Yep, all done. Let's deploy to Versal. And let's see what we have. Let's see. Able to deploy. Yes, it has deployed successfully. Open. It'll open in a new browser window. Just minimize this, and this is what it has opened. I think my screen is visible, so this is awesome. Looks very similar to Uniswap. Select amount, connect wallet. Should have a connect wallet here. Swaps, pools, deploy. Perfect. So this is on Safari, so it may not open, but I mean, we don't have an extension here, but we can keep improving upon this. And, we can also enable deployment with the confidential smart contracts, which we will do with the next video. But for now, this looks really cool. This is what you can build with Matterhorn, a full Web3 application before lunchtime and after breakfast. So just hour or two, I can go ahead and build the entire application, and this is pretty cool. Next, I will integrate all the confidential contracts as well and deploy those as well. But for now, this is how we create a full Web3 application with Matterhorn with a single prompt, and excited to see what users can build. Thank you.